Thanks for watching my video. Today we are going to discuss our fundamental theorem of calculus 1, okay? Or a fundamental theorem of definite integral, okay? Now our statement here says that if f is continuous, okay, function f of x is continuous on the closed interval a b, then we define f of x by this one, integral from a to x f of t dt. Now this integral has a derivative at every point between a and b, such that if you take differentiation of this one, then you get f of x. Okay. Let's try to prove this. Now let x be a point on AB. That means let x be a point between a and b in the closed interval, and Hayes Bn. Let's take Hayes Bn arbitrary small real number. Then from definition of f, we have from definition of f, meaning this one, from f of x is this one. So if I take f of x plus h minus f of x, which is f of x is this one, so f of x plus h will be integral from a to x plus h f of t dt, minus f of x is what, this one, integral from a to x f of t dt. And here we use properties of integral, but we are going to prove in the later part. Okay, this one I can rewrite in as integral from a to x f of t dt plus integral from x to x plus h f of t dt minus integral from a to x f of t dt. This integral from a to x plus h f of t dt is same as integral from a to x f of t dt plus x from x to x plus h f of t dt. So these two can get cancelled. Here we get integral from x to x plus h f of t dt. Now dividing both sides by, here we have f of x plus h minus f of x. Now dividing both sides by h, so f of x plus h minus f of x over h, which is equal to 1 over h integral from x to x plus h f of t dt. That's the equation 1. Now we are going to use mean value theorem for integral. From mean value theorem for integral, okay, we have proof in the later in my previous video. This, so our mean value theorem for integral, it says that we have a function f which is continuous on a closed interval ab. So there's another, then there is at least one number which belongs to c, belongs to open interval ab. That means a function f is, this is continuous on closed interval ab. Then we have other function which is c, that belongs to open interval ab, such that f of c is equal to 1 over b minus a integral from a to b f of t dt. So this is our mean value integral, okay, mean value theorem for integral calculus. So therefore from this right hand side 1 over h is, I can write in as what here, mean value theorem is says that from a to b. So starting from b minus a, that means upper limit first. So upper limit x plus h minus lower limit x, which is same as what, 1 plus h, no, 1 over h, integral from x to x plus h f of t dt, and this is same as f of c, okay, this two, if these two can get cancelled out, so you get 1 over h. So our right hand side in question 1 is nothing but f of c, okay, where c is some number, okay, some uh, some real number which is belongs to open interval AB, open interval AB. And this one, let's continue here. Now from 1 and 2 we have 1 is 1, 1 is this one, f of x plus h minus f of x over h is equal to, and this or right hand side is nothing but f of c from equation 2. So this is nothing but f of c. Let's make equation 3. Now let's take the limit so that we want to get this, the left hand side as differentiation df by dx, okay. So when h tends to 0, then x plus h will tends to what, x, of course x, and c tends to x, because since f is continuous, at x, so c will tends to x, which implies that f of c will tends to f of x, okay. Now when I take the limit on both sides, limit h tends to 0, f of x plus h minus f of x over h, which is equal to limit h tends to 0 f of c, and limit h tends to 0 f of x plus h minus f of x over h is nothing but differentiation, okay, or differentiation d by dx, I can say, and limit h tends to 0 f of c, which is this f function f of c does not contain h, so this limit will vanish, and we say that f of c will tends to f of x, of course. So this is our answer, df by dx. I can write it as d by dx of f, which implies d by dx of 1 is f, our function f is this one, integral from a to x, f of t dt. So df by dx is d by dx of integral from a to x, f of t dt, and this is again equal to f of x. So this is our theorem, this is our proof.